if no one else, I would assume Richard Minery or someone else has already explained it. Effectively, Andy Clark and Dave Chalmers are interested in what's called cognitive extension. Under what conditions can things outside of the biological skin count as having genuine cognitive power, part of a genuine sort of integrated cognitive ensemble. And that basically means for Andy, he's looking at the example of someone who has lost his memory, who he calls famously Otto. And Otto is trying to find his way to the Museum of Modern Art. And Otto basically uses his notebook, which has the directions, the address, to guide him there. And Andy's point is that why shouldn't we give some of the cognitive credit to the notebook? And that was a very controversial point. But even in that paper, Andy makes a few comments with Dave, basically sort of saying, well, we have to have limits, right? We have to avoid what is called cognitive bloat. So it seems sort of obvious that within the example of Otto using a notebook, someone with an attention deficit disorder, memory disorder, to get to the library, that maybe this would plausibly count. The notebook would count as part of Otto's mind. But I think it becomes much harder to say, where do you draw the line? Does the entire web, for example, count as part of the mind? And it seems like the answer should obviously be no, just because we have the internet and the web there, accessible via our desktops or our smartphones or whatever. It seems like the answer should be, that's as silly as saying a library should be as part of the extended mind. However, there are differing intuitions as regards the answer to this question. So if you ask someone like Tim Berners-Lee, does...
Sorry, could you lower your...
Okay, that's fine. That's fine.
No, just lower your speaker.
Yep. Okay, or whatever works for everyone. So if you ask someone like Tim Berners-Lee, does the web count as part of the extended mind? Does he feel like his mind is extended into the web? He says, why, of course. Whenever I have a new concept for a new program, I immediately do some code, chat with people in IRC, send it out to the web, and based on this feedback, we develop a new kind of program, a new kind of concept, new kind of thought, and thus he doesn't really see any particular difference between his cognitive operations and that of the web, at least in certain instances. However, I found Harnad at various points saying no, because obviously it seems sort of silly. While maybe Tim uses the web and he's creating new programs, a web, for example, can't have such obviously phenomenological problems, experiences, feelings, such as a migraine. However, the real question is, I think, is to some extent analytic philosophy just one giant misunderstanding? Because what we're dealing with, when we're dealing with questions like, does the web extend the mind, is we're essentially trying to refine common sense intuitions about how our natural language statements map onto basically some sort of conceptual structure. And the theory is that there's some sort of coherent, true conceptual structure that with enough argumentation, with enough natural language, clarification, we can actually obtain, to some extent, a clarification of our our common sense intuitions into a genuine systematic philosophy. However, I don't actually think that's what Wittgenstein and other people were saying, but we could save that for another time. I think more importantly is the fact that all of our intuitions are not historically ungrounded. That intuitions, our common sense beliefs, change from generation to generation. So it's not surprising when you talk to someone who's a bit older, even let's say the inventor of the internet, Vint Cerf, he would sort of say, well, of course the internet doesn't count as part of my mind. When you talk to someone a bit younger, say Tim, who's been heavily involved in web stuff, they say, of course it should count. And when you talk to people who are engaged every day in a sort of larger technological web-based scaffolding, the answer seems to move generationally from a previous pre-web generation, which did not in general consider the web to be part of an extended mind apparatus, to a sort of relatively plausible thought for many younger people, because actually they do have more extensive and intensive engagement with the web itself. And so just to clarify a few things, I think this is Sutton or someone else's here's point. one of the most sort of obvious, often misinterpreted points of the extended mind hypothesis is Andy and Dave in their original paper, they state what's called the parity principle. They sort of say, well, we're basically functionalists, and if something more or less does a task, if it looks like a duck and it walks like a duck, it's a duck. And thus, Otto's notebook should count as part of his mind because it's doing the same job his memory would do if it was inside the head, if it was neurally implemented. And you can make the same argument for, let's say, not just notebooks, but smartphones and all sorts of things. But I think the key difference, as brought up by Rupert and many other people, is that, well, that doesn't make any sense. Because it's actually, there are giant differences between, let's say, digital memory and neurological memory. That they just, neurological memory fades over time. Digital memory, at least under the right conditions, doesn't. And actually, this point was noticed at the origin of the Internet itself by the original funder of the Internet, J.C.R. Licklider over at DARPA, who basically said, actually, we understand that humans and machines are different. And that, but the fact of the matter is that difference is what's important. It's the complementarity which makes cognitive extension into digital media, into digital networks, important. And therefore, that's where he began what he called the man-machine symbiosis program, which led to, amongst other things, the Internet, because he felt that human beings, together with machines, could have new kinds of thoughts that neither of them would be able to think by themselves. But the question is, are they really having a new kind of thought, or just, as Licklider would often say himself, just a different kind of conversation? And another question, which often pops up when you look at the extended mind hypothesis, is the example as regards notebooks and memories. They all tend to deal with what's called dispositional beliefs, propositional attitudes. I believe that the Museum of Modern Art is effectively at this address in New York. I forget the precise one. But and you can also claim, well, of course, it seems plausible for someone who is disabled that they would have a extended mental apparatus because they're disabled. Because they simply don't have the cognitive capacities that normal people do. However, I think, and we see that, I would say that it doesn't have to be necessarily dispositional beliefs. You can see cases, such as artificial vision implants, which are very similar to Otto, where people basically, let's say, have light arrays projected to the nerves of their backside, and these nerves, the firings of these nerves on their backside in a sort of continuous reciprocal interaction with the optic array lead to sort of the formation of the feeling of seeing things, even though they don't see. And we're seeing these systems in the world, and would you say that this system, because this person's used to it, he solves problems doing it, he would feel disabled if he lost it? Should this system count as an extended cognitive apparatus? And to play the argument even further, seeing as that's not too different, it's not just a question of humans have some set of capacities or capabilities, and that sometimes these are disabled, and then disabled people can say replace them with new apparatuses, but the fact that everyone has a set of capabilities, and these capabilities are constantly being augmented by technology. So you see that it is not normal, and has not been normal for many generations, for someone to basically type into a box and get information, or to look at something and figure out where it is on a map. But now with augmented capabilities, such as given by Google Glass, we're seeing even people who would not otherwise be considered disabled being given new capabilities by technology, which extensively augment their existing cognitive capabilities. And in this way, it seems more and more plausible that we can imagine that if someone, let's say, as Larry Page, gets dependent on Google Glass, they get really used to the Google Glass, that they use it constantly, that they maybe couldn't survive without it, that we should count this Google Glass and some part of Google even, some part of this ability to get back the results as part of a dynamically organized cognitive sort of extension. And so I think what we need is new conditions that don't have anything to do with the original conditions, or at least that upgrade the original conditions of Chalmers and Clark around dispositional beliefs, etc. That seems sort of more plausible, that can handle cases where it's not just dispositional beliefs, but things like vision being augmented, and can handle the new kinds of technology that we're seeing spread every day. So, for example, this is with Andy Clark, these seem to be more plausible. So the first one is obvious, right? Portable. You don't really have a new capability unless it's accessible when you need it, under at least most circumstances. So, for example, if you have a smartphone, you want to count the smartphone as part of your extended cognitive apparatus, it has to be with you all the time, or at least most of the time, at least when you need it. But the same thing, you can run the same argument by biological tissues. For example, if your memory is constantly blacking out, if it's not accessible when you need it, how do you count your memory as part of a cognitive enhancement, cognitive capability? So it has to be robust, and that leads to the second condition. It has to work consistently and within a given time frame when needed. So one of the seemingly the big differences between just surfing on the web and using something like, let's say, a Google Glass or something is that you've noticed that the results come to you ideally more or less exactly when you need them. That you can't tell the difference in the ideal world between when you need the capability from your internal memory and when you need it from your external memory, when you need it from your normal biological perceptory apparatus, when you get it from your technological perceptory apparatus. So it has to be robust. And thus, that's why you see, particularly with Google, there's this very interesting focus on reducing the amount of time it takes to get a result. That down to tiny milliseconds. And that this is constantly the one thing that Google presses for. And I think that's because in order for something to be a genuine cognitive extension, it has to be robust and work within a given time frame. And these time frames are usually incredibly small. Okay, augmented. And this is where it's not just it can improve a missing capability, but the extension should provide a new capability, can also provide a new capability, something that humans just didn't have. And we see many examples of this. I think Menery went over quite a few of these. You've seen a continual enhancement of our memory via writing, via mathematics, our ability to, all of these sort of things are just, the web is just another version of this, but with some crucial differences, including this extremely low latency, this extremely wide ability to get different kinds of multimodal information, which kind of make it, I think, either significantly or possibly entire new capability given as opposed to previous sort of technologically augmented capabilities. And second, it has to be dovetail. It has to be the extension, the technology, whatever you want to call it, should be evolutionarily co-adapted. It should work with you in your environment and change with you as your environment changes. And that's something we're seeing. So, for example, something which is not particularly co-adapted is your normal web experience before, let's say, the rise of cookies and whatnot. Everyone would go to the exact same page, and everyone would have the exact same experience. But now what we're seeing is that the extension with cookies, personalization, machine learning, that these extensions are now being co-adapted to where you are, what you're doing. So again, just to go over these, it's portable, robust, augmented, and dovetailed. Thus, we can start making some principled answers to the question of, does the web extend the mind? We could probably say, well, look, surfing the web is not cognitive extension under most cases. Maybe for some particularly slow-moving task, maybe for some particular people who are constantly on their laptop. But in general, it's not, it can be somewhat portable, but it's still not particularly portable. It's robust, but not particularly robust. So for example, Wi-Fi may not be working, which is you don't have access when you need it. And it may not be particularly augmented. You may simply be looking at maps, and these maps can be very much sort of the same kind that you would have pre-web with sort of maps in front of your printed maps. Or you could imagine that when you're surfing the web, that it's not particularly dovetailed, that it's not particularly adapted to, say, your geolocation, what you ate, what you did last week. But now what we're seeing with the rise of apps, such as this wonderful translation app, is that maybe you don't want to call it a cognitive extension, but it seems like it should be much closer. That, let's say, geolocation-aware, trained smartphone might plausibly count as a cognitive extension, primarily because if you go through, it's portable, it's with you all the time. It's much more robust. If you have, let's say, global roaming data plans, that ideally would be very high speed, it would work everywhere. It wouldn't just stop working when you walked out of your particular Wi-Fi location. It would be much more augmented. The ability to instantly translate from any language is a significant augmentation of normal human translation language learning. And lastly, it would be evolutionarily co-adapted. It would be dovetail. That if you see this with the rise of, let's say, the quantified self movement and whatnot, but with massive machine learning over where you are, who your friends are, what you're doing together, I think you're coming much closer to a device which would genuinely count as a cognitive extension. However, I think what we've seen is that we're seeing a continuum of uses of the web. So on one hand, we have good old-fashioned web surfing on your laptop, let's say surfing of the kind that's happened since the 90s. Today, you're seeing this much more integrated use of the internet and web, where you can't tell, it would be hard to imagine how you would do some tasks today without the internet. With internet sort of impinges on everyday life constantly. And so I think that what you want is you want to sort of have a continuum. Well, on one hand, you have sort of cognitive processes which are merely distributed. That some part of the cognitive process counts as part of the mind. And on the other hand, some of them don't count as part of the mind, but they're necessary to perform certain cognitive tasks. And cognitive being anything with memory, language, attention, all that good stuff. And I think the sort of classic example here is brought by Hutchins in Cognition in the Wild, which is the example of effectively sort of how do people sail boats. Sailing boats is pretty complicated, particularly large mechanical ones, something that people can't generally do by themselves. And Hutchins' main point is that groups have cognitive properties that differ from individuals who constitute the groups, and that groups primarily work by some form of techniques. In particular, what Hutchins says, the propagation of representational state across a series of representational media. And so rather than thinking of is something part of the mind or not, it's probably better to think of things as part of a cognitive integration varying across a number of dimensions. That you have both individual and social cognitive integration and cognitive extension. You have individual cognitive offloading, where I simply, I don't remember everything someone's saying during a lecture, so I record it. I refer to that recording later. Two, individual cognitive integration, where without my smartphone, I simply can't understand what you're saying or get around. I can't finish my task. I can't even survive. And you're also seeing, I think you can replay this sort of dimensions on a social front. So you can sort of say, why not multiple people sharing cognitive state? And if you want multiple people share a cognitive state, I think you're talking about something which we'll return to shortly, called collective intelligence. But often what you really have is you just have social distributed cognition. So example, I land in Montreal, I sort of say, hey, what should I do tonight? I type that into Facebook, I get a result, I use this result to, let's say, guide me to a nice restaurant or a bar or whatnot. And that's obviously not cognitive integration, but there is some small element of socially distributed cognition there. But also you can see new effects, I would say, swarming and whatnot, where it does seem, that you're having some sort of collective intelligence. And so I guess the real issue with collective intelligence is how to nail it down as a concept. It's a remarkably fashionable word. It's very tricky to actually get right. My sort of proposition is that we should return to the work of Umberto Maturana, which has been applied to social systems by Luhmann, and apply it to techno-social systems. So Maturana, sort of obscure Chilean biologist, developed autopoiesis, where he basically claims that organization is a circular organization which secures the production and maintenance of the components that specify it in such a manner that the product of their functioning is the very same organization that produces them. So Maturana was inventing this thinking about biological cells. He was sort of saying, hey, what distinguishes a biological cell from a non-biological anything, really? And it's the fact that, by process of existing in the world, it maintains a sort of homeostasis and it reproduces its cellular form. So even if some components of it die, it's constantly regenerating them. And I think you could just sort of say collective intelligence is a form of autoprasis which goes beyond this biological skin of a single individual or any biological organism, and it creates a self-reproducing and modifying intelligence, as in something that can solve problems, that includes connecting multiple individuals via their technology and satisfies the conditions of cognitive integration, which is a sort of real-time, co-adapted component that we discussed earlier. And there's sections to this. So there's a lot of, so the migraine objection is perhaps the one more interesting. So I've heard at least, I think you wrote this down at some point, Stefan, that you sort of said, the drawer paper is one I've read, is that you sort of say, well, that's all fine and good, but functionalists tend to ignore phenomenology. They tend to ignore real emotional states, which have real effects on our existence. And so therefore, it doesn't make sense that you could have a distributed migraine. I would actually say I'm not sure about that. So if you go to, if you've noticed, architecture, for example, has a distinct influence on how people feel. There's emotional maps of cities. This goes back to the Situationist and whatnot. And that when your people, for example, even very simple everyday examples, are at a concert together, some sort of musical event, and they sort of feel the same emotion. Or you have crowd behavior, where you really feel that the crowd is excited all at the same time. And most importantly, think about the Facebook example, where Facebook was looking at how we can manipulate people's emotions by changing the algorithms of what shows up in their news feeds. That maybe you can provoke what are effectively some sort of distributed emotional states. So I'm not sure if that objection actually holds. And then there's Rowland's ownership objections. He would say, well, I think he's in the audience somewhere. He would sort of say, well, it's very Heideggerian. What is it which has the experience? What is it that's cognitive extension? That there is some irreducible core. So maybe we can have cognitive extension, but there still has to be some sort of human in the loop. That this human, and therefore, so I could say maybe parts of the web count, but ultimately the intentionality, the directedness of intentionality comes from something that's kind of special about how my neurons are configured. Being a more liberal functionalist, I would disagree, and we're going to go into that right now. And I think the key is, and this is a limit to autoprasis, and this is a limit to a lot of thinking in this space, that collective intelligence is not just, cognitive extension is not just cognitive extension. That the cognitive extension in general is just symptomatic of a wider, what I call ontological turn, where ontology is simply all the things that exist. So normally, in analytic philosophy, you assume you sort of know the things that exist. Maybe you don't. Maybe you can prove that you can't know them personally, but that the sort of folk ontology of the world is considered unproblematic. But when we start questioning this ontology, such as do we actually have individuals? What happens is an individual with a smartphone really different from an individual without a smartphone? When we start looking at sort of larger group behaviors, things we don't understand, that maybe what we're seeing actually is that the web isn't just influencing cognition per se, but that the web is actually transforming the scope of things that normally existed pre-web. That the ontology of the pre-web world is now transforming rather dramatically. And this is what we call the ontological turn. And I kind of go through this in vast amount of detail in my book, which is my thesis. But traditionally, just to go to semantics, so semantics is a study of how do we line up effectively some sort of sentences, some sort of representation with things in the world. And on the web, this is done. A URI is what's called a uniform resource identifier. The thing which is amazing about the web is that effectively all sorts of names, an infinite number of names can be created, and these infinite number of names can point to what's called any item of interest, which is any item of interest is a resource. And traditionally with the semantic web, you basically line up a name, and this is also the same for traditional Fregean and Tarskian model theory, but just kind of put on to the web, with a bunch of logical descriptions. These logical descriptions sort of line up to certain mathematical models, which then define inference rules. That's all this fun stuff in the semantic web, description logics and blah, 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 which no one really uses, but we can pretend they do for academic publication's sake. And then that these models then refer to the world, that they line up to the world and they work because the mathematics of the models lines up to the world itself. But what you see is that when you make the world itself problematic, it becomes much harder to line things up. And so you can sort of create these huge ontologies. So this is an ontology I created describing how the web works effectively, with URIs, information resources, and descriptions, and media types, and web pages, all these sort of things. What's accessible, what's merely identified, what's referenced. And what became more and more clear over time is that actually these mathematical constructs were not clearly identifying any sort of set, discrete number of individual objects in a finitely bounded and unchanging world, but that actually these ontologies were tools, just like hammers are tools or anything is a tool, that were essentially socially constructed. As Gruber says, every ontology is a treaty, but also every ontology is a tool, that they're also constructed to do certain things, to solve certain problems, to formalize just enough of the messy world to get something done. And what you've sort of seen, and this is what I did a large amount of relatively well-cited work on, is that rather than use sort of very complex formal systems, in general, systems on the web tend to be quite messy. And the obvious example of this is collaborative tagging. So that basically there's a process in which over time, and this is it's in this paper, but this is the sort of consensus emerging, so to speak, that being no consensus, that being quite a lot of consensus, is that over time, effectively, people would create these very lightweight representations. Tags are really just lightweight representations of content. And manipulate them and use them to socially coordinate, and eventually sometimes reach consensus, sometimes not reach consensus. And that actually what you saw is that these sort of representational models did not have a traditional, obvious kind of Fregean semantics, but they did definitely have some kind of dynamic semantics to deal with essentially a very messy, large-scale world. And that these sort of tools I consider to be more like language games, socially constructed, social semantics. But we can generally understand tagging, and this is, I'm just going to give I think a really problematic example that reinforces this point about ontology and semantics, is that while semantics sort of connects representations to the things in the world, that there's lots of things in this ontology that we may not know. So this is a sort of epistemological question. What part of this ontology is it capable for humans to cognitively grasp, to understand? So often today, and this is actually a map of protesters from Occupy. They sort of list which groups they belong to, and they list which networks they are in, and who's the top influencer that connects to different networks. That often what you have today is you have this sort of machine learning process that creates these profiles. And these profiles are then, let's say, used and to identify someone. This act of identification has a real effect on the world. And why do people do this sort of network mapping? They do this sort of network mapping because in their heads, without the aid of this visualization, without the aid of this machine learning algorithm, without the aid of trying to grasp what these clusters mean, they could not find the top influencer, which in this particular, I think, FBI simulation was someone they decided that they wanted to arrest. And of course, that when you have these sort of algorithms running, and you create these things called profiles, and these profiles then have real effects on the world. Someone goes to jail. And the question then becomes, interestingly enough, what is a profile? And here it's pretty simple. You know, a profile is just simply a set of people. We're looking for the person who we'd like to arrest. And you can sort of see these different networks, and we can sort of basically understand more or less what we think that algorithm is doing and what a profile means. We can understand that using our common sense understanding of the world, our common sense ontology, and thus it's kind of epistemologically unproblematic. However, that's not what most machine learning looks like, right? So if you've ever done any machine learning experiments, most of the time you have the results are not easily graphable. They're not easily interpretable. The set of attributes which map to particular classes does not map to any known class. Okay. And thus, this is what I call cognitively opaque. That you can't, it's not transparent, you don't understand what's going on, and this is sort of machine learning that actually most of the web is doing. If I used to work at a search engine company. If you ask someone in the search engine company, what do the parameters in that search engine mean? What does tuning them do? They don't know. They can't tell you. There's no common sense explanation. They simply manipulate the parameters based on feedback, based on data mining, and try to get that machine, that giant search engine, to do something a bit better, which in this case would be, let's say, find search results. But in the case of profiling, could be determining classes of people to ads to. And so what you're seeing is that you're seeing a transition from a world, and this is some original, sort of the original world of artificial intelligence. We're trying to build machines that inhabit the same kind of world that we do, that use the same ontology that we do, that we're trying to see, can we augment machines so they have some of the same epistemological characteristics that we do, and can thus successfully commit some of the same actions, to this world of massive machine learning in Google, where you have these profiles created of people. Profiles which are cognitively opaque, which you don't understand, which Google doesn't understand. And they're trying to basically nudge, let's say, people to make better decisions, to buy this product, not buy this product. And that these sort of larger, non-cognitively transparent objects are actually considered a real ontology. It's just an ontology that we don't understand, that doesn't map well to our pre-web existence. And that's the point of collective intelligence. It seems odd saying, hey, at certain points, part of my smartphone and the web, plus these machine learning algorithms, which are kept on a giant server farm in California, plus all the sensor data, which is being collected by various sensors spread throughout my town, that we think it's odd that this would somehow create some sort of unified object, something which is actually integrated. It doesn't seem plausible. We don't see that object. We don't feel that object. But nonetheless, objects that we don't see, that we don't feel, objects that we don't know if they exist or not, can have real effects. That's the entire point of the industry that runs the web right now. Behavioral targeting, that real effects on your behavior, on what you buy, on who you know, what you go to, based on essentially statistical machine learning that even the people running the algorithm can't really explain. All they know is maybe it works, maybe it doesn't. It's even kind of unclear often that the returns from investment are actually stable. And I think that this is where cognitive science is to step back and sort of say, well, what is it? What is, and I think Brian Cantwell-Smith gives the best explanation of this, or his Adrian Cousins, for example. What is it? How is it that we actually do objects come to be? How is it that ontologies come to be? How is it that we can have something which we call an individual? And this, I think it's often hard to tell, but when you have a sort of larger new ontologies forming due to massive technological change, such as that given by the web, they can have real effects on the world, you know. You can maybe buy something rather than not buying something. Stock market prices can go up and go down. And these sort of massive amounts of effects, which are often very discriminatory, are causally efficient. They're causally effective. And I think Adrian Cousins called these cognitive traces. They're pre-object. They may be epistemologically not understood. We may not be able to sort of grasp this particular ontology right now, given our current cognitive framework, but doesn't mean they're not real. So this is the final bit, is that, you know, this is where it gets hard. So what we're sort of saying, which I think is that engineers, when they create things, are designing new worlds, new ontologies, even if they don't realize it. They're often just trying to solve a simple problem, but they're creating whole new spaces of objects. And this is what Tim Berners-Lee called philosophical engineering. Essentially, they're engineering philosophy. Sort of and then we have a little book on this, if you're interested, by myself and Monin. And I think the really hard question is, if we do have a world in which a lot of the world is not cognitively transparent, when we do have a world where new kind of ontologies are emerging, where our sort of ability to even discriminate between what our individual intelligence is and some sort of wider distributed cognition or even collective intelligence is, if we can't really tell where these begin or end in this particular historical moment, how do we take responsibility in this age of transition? And Tim Berners-Lee has this sort of campaign going on now called The Web We Want. Where he sort of says, after the NSA revelations, it's clear that something's gone horribly wrong with the web, and that this sort of larger technical apparatus, which is possibly a sort of mechanism of collective intelligence, is actually being used against the people that contribute content, the people that use the web, for, let's say, the uses of certain nation states. How can we move from the web we want to the world we want? How can we engineer technologies which have the kinds of effects that we can grasp in this day and age as being something that we consider ultimately ethical, even if we don't understand, we cannot epistemologically grasp the ontology of this new world that we are entering into? And I think that's the last bit of this talk. So, any questions?